that there's is it an even function is equal to an odd function?
No. Something super important that we will always check.
They already take the antiderivative?
No.
Is it not continuous?
Very good. X cannot be 0. 0 is in the interval -1, 2. FTC does not apply. Very good, thank you. Questions? Questions? I know we have, and I'll let you decide, I know we have 9 minutes left. Would you like to practice more, or you would like me to talk about Fundamental Theorem of Calculus Part 2?
Let's say part 2 for next class.
Okay, perfect. So let's choose something else. So we cannot choose find the derivative of a function in a form of an integral yet. Anything else?
How about that 51? That looks smaller.
Yes, let's look at 51 and let's look at 52. Very good. So let's start with 51. So the integral from 0 to 4 from 2 raised to s ds. And let me also copy on the side 52. The integral from 1/2 to 1 over the square root of 2 from 4 over the square root of 1 minus x squared dx. Perfect. So now I can stop sharing. Good. Okay. So let me refresh your memory. When we differentiate e to the x, we get e to the x. But when we differentiate a to the x, anyone remembers what this equals to?
Is it 8 dx times ln a?
Excellent. Good. So keep that in mind. That's what we're trying to do here. So the integral from 0, thank you very much. Who said that?
That was Josh.
Thank you. So now I'm asking myself, this is s. I'm asking myself what function prime is 2 to the s. So I want 2 to the s. So it has to be 2 to the s divided by natural log a from 0 to 4. Let's take a moment. When I differentiate 2 to the s, I get 2 to the s times natural log, which will simplify with this, and I get 2 to the s. So now when I plug in 4, the constant stays outside. 1 over net, of course, yes, of course, it's natural log 2. Okay, when I plug in 4, I have 2 to the 4th, minus when I plug in 0, but 2 raised to 0 is not 0, but it's 1. So, yes? Anyone, please? Somebody wanting to say something? Oh, no worries. So 2 to the 4th, 16, minus 1, 15, over natural log 2. Okay, let's do 52. And we can stop if you want after that, unless you have questions. So in 52, we have the integral from 1/2 to 1 over the square root of 2 from 4 over the square root of 1 minus x squared dx. And like with the previous properties, 4 goes in front. It's a factor. So I can write it like this. I don't remember now if I wrote that. So the integral from a constant times f of x from a to b. I may have not written this one. C, the integral from a to b from f of x dx. Sorry about that. So please add it in. Good. So now I have 4, and I have to find the function whose derivative is this. Anyone wants to help? Which function prime is 1 over the square root of 1 minus x squared?
Is it an inverse trig?
Very good. Arc sine from 1/2 to 1 over the square root of 2. Great job. So 4, I plug in 1 over the square root of 2, which is the same thing with the square root of 2 over 2, minus arc sine of 1/2. So 4. Anyone remembers which angle in the first quadrant has sine the square root of 2 over 2? Minus in the first quadrant, thank you, which angle has sine 1/2? Very good. So we find the least common denominator. This needs a 3, this needs a 2, so that's pi. Simplify, and we get pi divided by 3. Any questions?